So multiplying polynomials, I'm going to start off with our most basic kind of multiplying polynomials, and that happens when you have a monomial out in front of a polynomial of some kind. So what's my monomial here? 5ab. 5ab is my monomial. If I have a monomial out front, what am I just going to do? Distribute. This is your basic distributive property. So I'm going to take 5ab and I'm going to multiply it by 3a squared. Well, 5 times 3 is 15. What do I get when I have a times a squared? A to the third. We're going to add those exponents. And then a b, no b there, so I got to keep the b. Now I'm going to take 5ab, multiply it by the next one. What's that going to give me? Positive 35, a, and then b to the second. And then finally multiplying by the third term gives me negative 10ab. Easy peasy? Okay. Is this written in standard form now? What letter am I concerned about when I'm talking about standard form? The letter that comes first alphabetically. So in this problem, I'm worried about the letter A. So I need to be able to count down with my A exponent. So I have the a to the third first, and then I have an A term, and I have another A term. Uh-oh. Are those two like terms? No, because even though the A matches, the B's don't, because one's B squared and one's B. So I can't combine those terms, and if we're talking about standard form, it doesn't matter which one you write first, as long as both of them come after the a to the third. Okay? So I'm going to say we're good there. Most people will put that in that order. Okay? Easy peasy? Let's move on to another one. Now this time I'm not going to do a monomial. I have a binomial times a trinomial. Now, there's two different ways that we could do this. I'm going to show you both ways. I'm going to show you one method on number 2 and another method on number 3. I don't care which method you use as long as you're using it correctly. Okay? So I'm going to start off showing you the distributive method. This is often seen like the foiling method, but foiling really only works when you have a binomial times a binomial, because that's the only time you have firsts, outers, inners, and lasts to do that. So a more accurate description would be the distributive method. So I'm going to distribute like I did up here. Okay? Now, I have two terms in this first parentheses. I'm going to pretend like the second term doesn't exist right now. And I'm just going to look at that 2x. And I'm going to take that 2x and I'm going to distribute it through just like I did up here. Okay? So we're going to pretend this minus 5 isn't there. So if I take 2x and I multiply it over here by 3x squared, what do I get? 6x to the third. And then if I take 2x and I multiply by negative 10x, what does that give me? Negative 20x squared. And then finally 2x times positive 7, positive 14x. So I'm done with that 2x. Now I'm going to pretend like the 2x doesn't exist, and I'm going to take the 5, or the negative 5, and distribute it. So negative 5 times 3x squared gives me negative 15x squared. Negative 5 times negative 10x is positive 50x. And then negative 5 times positive 7 is negative 35. At this point, all I need to do is combine my like terms and make sure my answer is in standard form. So, what's the highest exponent that I should put first? X to the third. Are there any terms besides this one that have x to the third? Okay, so that guy comes first. 6x to the third. Next, I would go to x squared, right? I have one there. I have another one there. And I think that's it. What's negative 20x squared and negative 15x squared? negative 35x squared. Now I'm going to go to the x's. I have an x term here and an x term here. 14x and 50x give me 64x. And then finally I have this minus 35 with nothing to combine, so that would be my answer. Easy peasy. Okay. So that's the distributive method. Now I'm going to show you the box method. Okay, different problem here. So here's my problem, and we're going to do the box method here. Raise your hand if you prefer the box method. Do you know what it is? Okay. I will tend to use the distributive method just because that's my preferred one, but you are welcome to do the box method whenever you need to. As long as you're doing it correctly, there's no harm in doing it. Okay? There's not one that's better than the other. It's whichever makes sense for you. So, in my first parentheses, I have a binomial, which means my box needs to have 2 rows in it. So there's a 2-row box. In the second parentheses, I have a trinomial, which means I need to have 3 columns. So there's my 2 rows. I need 3 columns. So my box needs to be 2 by 3. So far, so good? This binomial, I'm going to put 1 term on each row. So 3x on the first row, negative 7 on the second. The next one, all of those terms are going to go on the columns. So 2x squared, and then 12x, and then 6. So far, so good? Now I'm going to treat it like a multiplication table. 3x times 2x squared is, use a different color here, 6x what? 6x cubed, okay. 3x times 12x, 36x squared, and 3x times 6, 18x. So far, so good? Second row, negative 7 times 2x squared, negative 14x squared. Negative 7 times 12x, negative 84x. And negative 7 times positive 6 is negative 42. Now, the benefit of using the box method is if both of your polynomials are in standard form, your like terms are very close to each other and easy to group together. So this would give me a result of 6x to the third. My x squareds are diagonal from each other. 36x squared and negative 14x squared would give me what? 22x. Positive 22x squared. Negative 84x and 18x. Negative 66x. And then minus 42. Okay. So some people will come and ask me which way's faster. They're both about the same. The box might be a little bit longer actually because you have to draw a box. But if you were to do this distributive method, these terms in here are all the terms that you would get in this step. So you're doing the same thing, it's just a different way of organizing your process. Okay? Again, I don't care which one you choose to do, just do it correctly. All right, let's try a couple more. Here's the first one I want you to try. You try that one. Use either method. Now I have a question. Does it matter if I write this as xy squared or y squared x? Does it matter if I put the x or the y first?
Yeah.
It actually doesn't matter, but it's going to be easier in the long run if you keep things alphabetical, because it'll be easier to see what you have that are like terms. So I'm going to call this xy squared when I multiply it. That way I can see that it's a like term with what I got in the previous multiplication. Okay, and I have positive 6y to the third. So, standard form, what letter am I concerned with? X. You might be tempted to be concerned with y because the highest exponent in this problem is on a y. But since x comes first alphabetically, we're going to stick with that one. What is the highest x exponent? Squared. So this term with the squared, there's no others that are like terms, so this guy's got to go first. Next would be my x to the first term. Well, I have two of them, and those two are like terms because not only the x's match, but also the y squareds match. So what do I get total there? Negative 13 xy squared. So I have x to the second, x to the first. My next term should be x to the 0, or the one that doesn't have an x term. So it's that guy, plus 6y to the third. Easy? Okay, I have two more to try and hopefully challenge you, though it's probably not going to challenge you because how hard can you make these? So, here we go. Last two. Two x minus 3y and 2x plus 3y. What do you notice? They're the same except what? The sign. Is that familiar at all to you? You probably learned it as a difference of squares. Now this itself isn't the difference of squares. The answer is a difference of squares, because when you learned about the difference of squares, you were actually doing factoring, which is the reverse process of what we're doing here. So what's going to happen when you go through is you're going to end up canceling some things out in the process. Okay? I'm going to go ahead and use the box method on this one, since I did distributive on the other one. So 2x and negative 3y, and then 2x and positive 3y. If you would rather use distributive property, that's fine. You should end up with the same answer. So 2x times 2x is 4x squared. 2x times 3y is 6xy. Negative 3y times 2x is negative 6xy. And negative 3y times positive 3y is 9y squared. What do you notice about the like terms? They cancel out because 6 and negative 6 give you 0. So in that difference of squares, those cancel out, and I'm left with 4x squared. I didn't multiply that right. That should be a negative 9y squared, right? Yeah. So do you see the difference, the subtraction of squares there? That's where it ends up. Okay? Last one. What do I do with that squared outside the parentheses? Do I distribute it in there? You might be tempted to, but you actually can't. Whenever you have addition or subtraction inside parentheses, we can't just distribute that exponent. So what do I have to do? I have to actually write it 2 times and multiply it all out. Okay, so go ahead and finish that multiplication, either method. Combine your like terms and see what you get. So this is similar to the last one, except what do you notice about the like terms? And I have this wrong here. That needs to be a minus. What do you notice about the like terms this time? They don't cancel out. They add together, don't they? So 9x squared y squared minus 48 xy squared plus 64 y squared. Is that in standard form? Because if I go by my x's, which comes first alphabetically, I have x to the second, x to the first, and that would be my x to the 0 term because there is no x. Questions? All right, easy peasy. All right, here comes your homework.